Hey everyone, just want to welcome you to week 3, module 3 for ME 144 heat transfer course. So this module we're going to do is we're going to start chapter 2. Now I know your homework 1 covered a couple problems from chapter 2. This was intentional. I wanted you guys to be reading in advance. You still have all of Monday. This will be coming out 6 a.m. Monday morning, and you'll have till the end of the day Monday to do that. But I wanted you to read ahead in advance. This was my way of double checking that you guys are preparing for the lectures for the week. So chapter 2, we're going to begin with an introduction to conduction. We're going to talk about conduction rate equation. We're also going to discuss the thermal properties of matter, and then get into some problems with the heat diffusion equation and talk about the importance of boundary and initial conditions with these different problems. So some bookkeeping items. This week we have quiz number 3. This will be posted Monday morning and due on Friday by 4 p.m. And again, a reminder for homework 1, this was assigned last Monday and will be due at the end of the day on the 15th. So you'll still have that to do, and like I mentioned, there will be 2 problems on that have to do with content from this chapter 2 that I had expected you guys to read in advance from the textbook. Reminder, my office hours are scheduled on Mondays from 10 a.m. to 11 a.m. If those times don't work for you at all, please send me an email or chat. The TA also has office hours schedules you guys should have received the invitation to as well. So again, if either of these times don't work for you, please reach out. I have Teams set up on my phone and my home computer, so I am around most of the days, so let me know if you need to get a hold of me, and again, we'll find a time that works for both of us. So as we jump into module 3, we'll be referring to chapter 2 in our textbook here. And during this module, we're going to develop a deeper understanding for Fourier's law. We're going to look at its origins and the form it takes for different geometries. We're also going to examine how its proportionality constant, or the thermal conductivity, is going to depend upon the physical nature of the medium that we're dealing with. We're also going to take a look at our heat equation as well, and this governs the temperature distribution in a medium. So the solution to this equation provides knowledge of this temperature distribution, which may be used with Fourier's law again to determine our heat flux. What we've talked about with heat flux is going to come back again in this module and in this chapter number 2. So within this module, a couple of the main topics that we're going to cover: the conduction rate equation, thermal properties of matter, thermal conductivity, a couple other relative properties that we'll discuss, the heat diffusion equation, and then take a look at the importance of boundary and initial conditions. So we're going to break this module down into 2 different sections here. Now the first module, we're going to go through the theory behind everything, look at our governing equations, taking a look at Fourier's law, heat equation, boundary initial conditions, thermal properties, and typical methodology of a conduction analysis. So we're going to cover all the theory and governing equations of these topics in the first module here, in the first section of the module here. When we get to the second section of the module, we're going to get into some practical applications and some solutions to a couple different example problems. So that's what we're going to do as we move on to 3.2 here. We're going to take a look and apply the concepts and equations that we saw in module 3.1 to a couple different example problems, and I'm going to go through my hand solutions and relate these back to some of the governing equations that we saw in the first section of this module.